Think back to school for a second. Remember that simple diagram of the water cycle? Evaporation, condensation, rain. Just this perfect, reliable loop. It's always felt like the planet's heartbeat, right? A constant rhythm, moving water from a faraway ocean to the rain falling right outside your window. Well, here's the thing. That steady, predictable system we all learned about, it's changing, and it's changing fast. The fundamental plumbing of our planet is under a kind of pressure it's never seen before, and we're really starting to see the cracks. Okay, so let's get right into it. There are really two big drivers here. First, a warming climate, which is basically just pumping a ton of extra energy into the whole system. And second, our own activities, everything from how we farm to where we build our cities. These two things together are supercharging the water cycle and kind of short-circuiting it at the same time. So what do we mean by accelerating? Think about it this way. Heat is just energy. As we add more energy to the atmosphere by warming it up, the speed of evaporation goes up globally. That means water is zipping from oceans and lakes into the air way faster and much more intensely than it used to. We're kind of shifting from a predictable waltz to a chaotic mosh pit. So let's start up in the air, in the atmosphere. The very air around us is holding and moving water in totally new ways now, and it's creating this world of wild extremes. And this right here is the central paradox, the real head-scratcher of the whole thing. On the one hand, since there's more moisture up in the air, when it finally does rain, it really, really pours. We get these much more intense storms and floods. But on the other hand, those exact same warmer temperatures are baking the soil dry in other places, leading to longer, more severe droughts. We're literally getting too much and not enough all at the same time. And all that extra heat, it's not just staying in the air. Get this, over 90% of the excess heat we've generated has been soaked up by the oceans. Warmer oceans are basically super fuel for hurricanes and tropical storms. It turbocharges them, making them way more powerful and a lot more dangerous when they finally hit land. Okay, so let's move from the air down to the land. The story here is a weird one. We're unlocking water that's been frozen for thousands of years, while at the same time, we're losing the hidden water we depend on every single day. First, just look at the sheer scale of the melt. By the end of this century, the world's glaciers could lose up to half of their total mass. Now, this is more than just losing some pretty scenery. This is a massive, one-time dump of fresh water into the system, water that's been locked away in a deep freeze for ages. And it's not just the glaciers either. Something really profound is happening up in the Arctic. The permafrost, that's the ground that's supposed to be permanently frozen, is thawing. And as it thaws, it completely rewires the plumbing of the landscape. The ground gets all spongy, water sinks deeper, and it's fundamentally changing entire ecosystems from the ground up. So while all that ancient ice is melting up on the surface, we're busy draining our hidden water savings accounts, the water stored deep underground. Now, this set of maps might look a bit complex, but just focus with me on map D, the one on the bottom right. See all those yellow and red areas? Those are the hotspots, places where groundwater levels are dropping like a rock. We're talking about the U.S. High Plains, the Indo-Gangetic Basin in Asia, the Middle East. These are the breadbaskets of the world, and we're pumping out that water way faster than it can ever be replaced. Now, there's one last huge player on land we have to talk about, our forests. As this quote from the journal Nature points out, forests aren't just sitting there looking pretty. They are active, essential participants in the water cycle. They help make their own weather. And this is what happens when we lose them. See, forests recycle moisture. They literally breathe out water vapor, which then becomes the seeds for new rain clouds. When we chop down huge areas of forest, we break that loop. It's not a theory. Studies across the entire tropics confirm it. Deforestation causes a real, measurable drop in local rainfall. So, you've got melting ice pouring off the land, you've got shifting rain patterns, and all that extra heat. Where does it all end up? Well, it all ends up in the ocean. The ocean is where pretty much all of these consequences finally meet. So why are sea levels actually rising? It really boils down to two pretty simple things. First, we're adding new water. That melting ice from glaciers flows into the ocean, and boom, more volume. But second, the water that's already in the ocean is actually getting bigger. It's called thermal expansion. When water warms up, it expands and takes up more space. And since the oceans are soaking up so much heat, this is a huge, huge factor. And the potential scale of this is just wow. If we keep going on our current path, we could see as much as 1.1 meters, that's about 3.6 feet, of sea level rise by 2100. Just take a second and imagine what that means for every single coastal city and community on Earth. Look, I know this all sounds massive, maybe a little abstract, but these huge global changes are tied directly into our daily lives, often in ways we don't even realize. We're not just watching this happen, we're actively involved in the cycle. Let me introduce you to this really fascinating idea called virtual water. Basically, it's all the water that was used to produce something. So when you import, say, coffee from Colombia or avocados from Mexico, you're not just importing food. You are, in a very real sense, importing the water it took to grow them. It's a hidden global trade in water. And this is not some small niche thing. About 11% of all the non-renewable groundwater that's being pumped out of the ground globally is directly tied to the international food trade. Our dinner plates are directly connected to draining those critical underground water reserves we saw earlier. But even when we try to do the right thing, it can get complicated. Take planting trees, afforestation. That sounds like a no-brainer. 100% good, right? Well, in dry regions, it can actually have a surprising downside. If you plant huge forests of thirsty trees, they can suck up so much water that they actually lower the water table, preventing that groundwater from recharging. It's just a powerful reminder that in a system this complex, there are no simple one-size-fits-all solutions. So, where is all this headed? What we're seeing aren't just a bunch of separate problems. They're all connected. We're seeing these complex feedback loops start to kick in, and they are fundamentally redrawing the water map of our planet for good. And here it is. Here's the feedback loop that ties so much of this together. The connection that might just blow your mind. When we pump huge amounts of groundwater out of the earth, say in the middle of a continent like North America, that water doesn't just disappear. It evaporates, it rains down, and eventually most of it finds its way to the ocean. We are literally moving ancient water from deep underground to the sea. And by doing that, we are directly causing sea levels to rise. And as you can see from this chart, this isn't some small, trivial effect. Yeah, thermal expansion is the biggest piece of the pie, but our pumping of groundwater is already responsible for a huge chunk of the sea level rise that's already happened. It's this massive and often totally overlooked piece of the puzzle. So what's the big takeaway here? I think it's this. We've gone past the point of just living within the water cycle. Through our energy choices, our farming, our cities, we have become the chief engineers of this entire planetary system. We have literally replumbed the Earth to serve our needs right now. And the massive question that leaves us with is, in doing all that, have we broken its ability to sustain us in the future?